So the two other things we're going to talk about in terms of economics is consumer surplus and producer surplus. So this video is going to be on consumer surplus, and then there'll be another one on producer surplus. So when consumers buy products in the market, they may pay less than the full amount they're willing to pay. This is called consumer surplus. Consumer surplus equals the maximum amount you are willing to pay for an item minus what you have to pay. So for an example, say there's a computer that you want and they are charging $1,000 for it, but you're actually willing to pay $1,500 for it. That extra that you're willing to pay is called the consumer surplus. So when we do our surplus and our supply and demand and graph them, the consumer surplus is this region. So it's created by the demand curve. And the equilibrium point, again, we often call it Q star, but this equilibrium point, this X value, where it will be, that's the point that they're selling it to at that equilibrium point. But consumers are willing, depending on the price point, to pay more than this equilibrium point. So when there was less products, when the demand, there was less quantity, so the demand is higher, they were willing to pay a lot more than the equilibrium point. As the quantity increased, they're willing to pay still more than the equilibrium point, but it's closer to that value. So this area in blue is that consumer surplus. That's the maximum amount consumers are willing to pay for an item minus what they actually will pay. Okay. So to find that, what we can do is we know that if we just had the supply curve, the demand curve here, and this again is my equilibrium point. This area here, this triangle, is the consumer surplus. So to get that area, because it won't always be a triangle, what we could do is we know that the area between this demand curve and the x-axis we can find by using a definite integral. So we could take the integral from, it's going to start at 0 to whatever this x value of equilibrium point, so Q star, of my demand curve, so d of x. Okay, I could take that integral and that would give me the area that I outlined in blue. But for the consumer surplus, we only want this area that I have in red. So I need to take out this area that I'm outlining in green or shading in green. And so we need to subtract that area out. To do that, we know that this is a rectangle and that the length of this rectangle is this Q star, the x value of the point of equilibrium. And the height of this rectangle is the P star, which is the y value of the point of equilibrium. So we would subtract out the area of that rectangle, which is Q star times P star, because an area of a rectangle is length times width, or base times height. And so this is the formula for consumer surplus. This is how we find the area of this region. So again, some textbooks use the capital QP. We often will more use the Q star P star. But this is how we would find the consumer surplus. So it's the definite integral from 0 to Q star, which is the x value of the point of equilibrium, of the demand curve, And then we subtract the area again of that rectangle, which is the Q star times P star. And the same thing if it's not a triangle, the same thing would be true. So this one, I can't exactly see where the demand curve intersects the x-axis, or sorry, the y-axis. But we would say like this curve somewhere intersects it. So for this one, again, the consumer surplus would be this region. And you would again find it by taking the integral of the demand curve from 0 to Q star, and then subtract out the area of this rectangle below it. And often they draw the supply curve on the same graph. So just know, again, I'm trying to take out this entire area and I'm just ignoring the supply curve when I'm doing consumer surplus. Okay, so let's look at that example that we did for the equilibrium point. We did this in the video before. We found that equilibrium point to be that 1050 and 129.61. So this was my Q star and this was my P star. And so we want to find the consumer surplus. So again, you can graph it to help you visualize it. But when we do the consumer surplus, again, the formula is always the integral from 0 to Q star. Okay, it's always the X value, which is the Q star of, so remember, if we look at our graph for the consumer surplus, it's always between the demand curve, so D of X, dx, and then we subtract out the area of that rectangle, which is Q star, P star. So it'd be the integral from 0 to, my Q star is 1050 of the 4200 over the square root of X minus this Q star P star, so 1050 times 129.61. So for this, we're only integrating this part, not this part. So for this, you might want to just do it on the side and then like put your answer back in. So if I just take this integral from 0 to 1050, I'm going to make it again x to the -1/2 so that I can integrate it. Okay, that becomes 4200 x. We add 1, so -1/2 plus 1 is a +1/2, and we divide by that new exponent. And we go from 0 to 1050. We're going to use that fundamental theorem. Let's simplify a little bit. So if you do 4200 divided by 1/2, which is same as like multiplying by 2, you get 8400, and then it's going to be the square root of X for that 1/2. And so that's going to give me 8400, the square root of 1050 minus 8400, the square root of 0. If I calculate that, I get 272,191, and we just do 2 decimal places because it's Monday. So this would be that integral. That's the area of the entire thing. And then we are going to, again, go back to our formula. We just found this part, and we're going to subtract out that 10,050 times 129.61. So we get 272.191, not point, comma, 0.11 minus, okay, let's multiply that out. So we'll do 1050 times 129.61. Okay, so I'm multiplying this out. and I get $136,090.50. And then we can subtract them. And then my consumer surplus is $136,100.61. And so that's the total extra that consumers are willing to spend on this product over what they're actually spending. Okay. So if you have any questions, let me know. I'll do a video of a few more examples of it then.